Hello and welcome to the Blockchain and Us, where pioneers and thought leaders talk about their journey in blockchain technology, crypto assets, and the token economy. And I'm your host, Manuel Staggers. This episode has support from no official sponsor, but from my very own The Blockchain and Us newsletter. Get an email from me every 2 weeks with a very short summary of new podcast episodes so you can immediately pick those interviews you'd like to listen to. To stay up to date, just visit www.theblockchainandus.com and sign up today. My guest today is Trent McConaghy. Trent is the founder of the Ocean Protocol, a decentralized data exchange protocol to unlock data for artificial intelligence. He has a PhD in engineering, where he focused on machine creativity, and he also advises Estonia, Germany, and other governments on strategies related to blockchain technology and AI. And now, to the interview. Hi, Trent, and many thanks for taking time today.
Hi, a pleasure to be here.
Trent, you have founded two companies in the data and AI space, Ocean Protocol and BigChain DB. Let's start with Ocean first. So what's the vision for Ocean and where are you in that vision currently?
Yeah, so the overall vision for Ocean is to create a data economy, one that has the principles and values of the blockchain world, the cypherpunk movement and so on, which is about equal spread of value, equal spread of power, and in the context of data, connecting the data halves with the AI halves. So basically there's these AI people, data scientists, et cetera, building models, et cetera, that unlock a lot of value. And right now they're not very well connected to all these people that have data. And instead we have these giant middlemen, the Facebooks of the world, that are finding ways to get data from people who don't realize how valuable that data is, and then mine that data with AI, and then keep all the value basically for themselves and their shareholders. So that's really what Ocean is about, is to manifest this new data economy where there's a much greater spread of value and of power.
And you mentioned already Facebook. Also, before we spoke, you said you deleted your LinkedIn account. I mean, does that have to do with this as well?
Well, overall, I've been a long-time Facebook user and LinkedIn user, or more like, people would add me as friends and I would say yes. And for the first few years of those, it was people that I had met face-to-face and so on. But as time wore on, I was getting less and less value from both of those platforms. And also I was becoming more and more aware of how I was essentially being people farmed, where they were extracting value. So I have deleted both my Facebook and my LinkedIn account. And before they do it for me, in a sense, potentially too, right? If you look at the terms of service, they say, we reserve the right to delete your account without any notice, et cetera, et cetera, et cetera. So I am preempting them, perhaps. I look forward to the time when we have, mainstream decentralized social media. Right now, we don't yet in a big way, but it's coming. So there's partly a values thing, but partly I no longer got value from them compared to the disbenefits of being on either of those platforms.
Mm-hmm. Was there a specific event that happened, that triggered that realization for you?
Not really. It was actually more of building up over time of awareness and frustration, and also, frankly, anger at what these platforms have been doing, right? They talk about connecting the world and so on, which they have, but at the same time, they're people farmed, and that to me is quite terrible. And in fact, even in the last couple of years, they have transformed from being more of a just pure technology platform without opinions to one where they've actually become more of a media company that actually has opinions, and they arbitrarily censor, which means they've essentially turned into governments. And that rubs very badly with me. I think we should, all of us, say in what gets posted where, from our perspectives, and this is the principles of free speech, et cetera, right? So, and the great thing about the overall blockchain movement is that it is about being censorship resistant, about being permissionless, about being independent of jurisdiction, and that's sort of a trend that's moving away from what's happening with the Facebooks of the world.
With your work with Ocean, you outlined what you want to do, basically create a data economy, but how far along the path to achieving that goal are you at the moment?
Yeah, so roughly speaking, we just released our alpha on scope and on time, which we're very proud of. That's very hard to do in software. And so we have 3 releases leading to the main net release on Ethereum. And so the main net release is targeted for end of March. You never know, that may change, but because it is hard to build and develop software on time, on scope, etc. But I'm very proud of the team that we've assembled. We've been in the space for 5 years now, from a scribe to big chain to big chain and Ocean now together. So that's roughly the timeline. There's actually a much longer sort of story that led to Ocean, and maybe we can get to that at some point in the conversation too.
Why don't you talk about that story now?
Sure. So I was raised in a pig farm in Canada, and I studied electrical engineering, computer science. And out of that, actually, my very first job was doing AI research, simply because I'd been hacking on neural networks in free time. It was a summer job. And in this job, I was given a bunch of data from radar signals, and I had to come up with a model that would automatically classify whether these signals were of birds flying by versus of people walking versus tanks driving by versus whatever, audio radar data. And so how that went was I had 20,000 data points, and the model had to predict one of these 13 classes. And at the beginning of the summer, I had an accuracy of 55%. So just over half the time it would be correct. And I worked over the whole summer. At the end of the summer, my accuracy was 65%. And from that same data set, and I played with neural networks and genetic programming and a bunch of other stuff. I thought it was wonderful fun. People were paying me to, do AI work, right? And that was really the start of my work as a sort of AI researcher, professional work, I guess. And it's interesting. That's kind of how, this was the mid-late 90s. And that's actually how AI was done then, right? It was all about a fixed data set and, building models from that fixed data set the best you can. And, most of AI was still academic then. So the KPI was really conference publications and citations and so on. And it kind of stayed like that, without many real world applications for a long time until the early then mid 2000s, when first of all Microsoft, Banco and Brilla, and then Norvig and others at Google realized the unreasonable effectiveness of data, where rather than having a fixed data set and trying to have the best algorithm for that data set, you just add more data, and not just 2x more data, but 10x, 100x, 1000x. And they found by doing this that they could go from 55% accuracy to 65, 75, 85, 95, 99, 99.9. And once you're at around that threshold, 95, 99, 99.9, you can actually deploy this stuff in the real world, right? So, and if you think about it, it's actually super embarrassing for an AI researcher, because now, all this hard work that you do inventing fancy algorithms, you don't necessarily need it. You just need way more data, and of course, way more compute and storage to manage that data and to train the models, right? But this is actually what, Google really capitalized on this. So they wrote this paper about it in the mid 2000s, and from then on, it was their whole game has been about grabbing data, getting data, and using that to build models, and then from that to sell ads, right? And that's exactly the model of Facebook too. So that's basically where AI comes in. And because I've been doing AI for a long time, I kind of understood this, watched it develop over time, and sort of bit by bit, it was sort of like frogs in a pot of water where it's boiling more and more and more.
Sorry to interrupt there, but I wanted to ask you, basically what you're saying is the algorithms are the same. The only thing that's changed is there's way more data today.
Way more data, and then of course the memory, the compute, etc., to store it, to train the models and so on. But the algorithms actually are essentially nonlinear neural networks, which were invented in the early 60s. The linear neural networks of the late 50s, perceptrons, all this, and then nonlinear on the heels of that. So the stuff hasn't changed, and it's just like massively more. There's a few tweaks here and there that help, for a 2x, etc. But conceptually, the overall thing is the same. And like I said, that's slightly embarrassing. But at the same time, it means that we can have these incredible applications, and like full kudos to all these work of these AI researchers where, they've managed to tackle hard problem after hard problem after hard problem and really solve it in a practical way using, these modern AI techniques, largely neural networks, but there have been other ones too. I spent a lot of time with simulated evolution, for example, and that's starting to have some really awesome applications too.
Interesting point. Because I always thought the challenge for artificial intelligence is software. But actually what you're saying, it is data and hardware.
Yeah, well, everyone assumed that it was software. Everyone assumed that it was algorithms, right? And, that's the rhetoric. Oh, we need to have better algorithms. We need to have better models of the brain, all this.
Yeah, exactly.
So But in the end, it wasn't. And, there's analogies from history too, right? For example, during the mid-1800s, there's a bunch of research from people trying to record sound and then reproduce sound. So there was researchers all over the world where they were making mathematical models of the voice box and of trumpets and all of this, and then trying to say, okay, once we understand this, then we're going to be able to reproduce it. And then along came this crazy guy who was trying to improve telegraphs. His name was Thomas Edison, and he'd had a patent here and a patent there on telegraphs. And he said, what if I just put the stuff on some wax paper, kind of almost accidentally, and then so he had this wax paper recording some vibrations of what was being said, and then he kind of played it in reverse, just like it had the sound. And like, oh, wow. And, that simple little device that was making some scratches on wax paper, it had no understanding of voice boxes and larynxes and all this. It was super simple, right? So it was the simplest thing that could possibly work. Just everyone assumed that the problem was complex, right? And that's actually what's been happening in the world of AI too. Everyone has been assuming that we need fancy models, et cetera, and algorithms in order to solve the problems. In the end, we just needed more data. And now we still have the same rhetoric, right? People are like, oh yeah, for AI to wake up and stuff, who knows how to do it? We need to understand the brain and model the brain and all this. Do we? Right? What's the simplest thing that could possibly work? What if we just have another 20 or 30 years worth of Moore's law, right? And some people have had models of, to get to the level of processing of the human brain, where $1,000 of processing is the same as flops as the human brain. That's 2045. That's some Kurzweil calculations. And of course, if you build a huge supercomputer beforehand, maybe you can do it 10 years or 15 years earlier, right? So, or maybe even 20. So to me, it's actually, I'm not saying that AI might wake up, but I'm saying most of the rhetoric is actually approaching it wrong, because there's this desire for fancy complexity that you have to design in. Whereas a lot of the stuff, you just have emergent complexity. You have very, very simple rules at the very heart of the system, and you have all this complexity that emerges. And by the way, that's how blockchain works too. Bitcoin, at the heart of Bitcoin, you have this very, very simple, elegant incentive system. It pays people if they add to the security of the network. And around all of that, around those very, very simple rules, we've had the emergence of all these miners and wallets and exchanges and the unlocking of the whole blockchain ecosystem more broadly from a very, very simple algorithm and incentive scheme, right? So this is the very idea of complex systems. So basically, that idea manifests in intelligence and manifests in blockchains, and it has practical implications for AI research.
Very, very interesting. Last year, actually, half the year I spent interviewing people on AI. And many people said data is actually the biggest challenge. Without data, you can't do any AI. But nobody said it's the same algorithms like from the 60s. So quite interesting. Why do you think people make these statements that they say we need to remodel the brain and understand it bottom up? And, you mentioned before they have a need for these fancy algorithms or this fancy approach to cracking AI. Why do you think they look at that and don't just have some common sense and do what you're proposing?
Well, I think, it's not, everyone has common sense in various ways, and it's sort of like, what's the model of the world? And sometimes ego can be blinding, right? So, or that's the way it's always been done, right? When I was doing my undergraduate design thesis, what I proposed to my professors told me, if that could have been done, wouldn't it have been done already, right? And I thought, I thought to myself quietly, like, game on, let's do it. And, they made a bet with a steak dinner that myself and my colleagues wouldn't pull it off, and we did. We did it, and we started a company from it. That was in 1999, and that was actually, AI for designing computer chips. So anyway, this is a common thing, and part of it is you also have to look at the incentive structure that people have. So in the world of AI, it's mostly been academia for a long time, right? What is their KPI? It's conference publications, and
funding raised.
Yeah, exactly. That's exactly it. So if you think about funding, what sounds better? Okay, I need a bunch of funding to buy some, a million data points, or I need a bunch of funding because I'm going to build new models of the brain, and I'm going to do, fancy scanning, right? So like one thing sounds a lot better than the other when you're trying to pitch it in front of a funding committee, right? But the mundane is often what works. And perhaps, because, the reason we've seen the explosion of sort of the use of data in the last 10 or 12 years was because companies like Google could figure out how they could monetize this, right? You have more data, it means you have a more accurate model, which means you can have more targeted ads, which means you can make more money from it, right? From ads, as an example, right? And the stuff that I've been doing in the world of AI too for designing computer chips, we actually had could do a bit more data, but we actually had limited samples simply because there was a finite amount of time an engineer would be willing to sit around to get the sort of samples from circuit simulation, et cetera. So we had more limited data to work with, but then we had to do the best we could. And knowing that there was limitations to the algorithms, you can't spend too much time on the modeling, we would actually just expose the models and the uncertainty of the models. So there's other ways to work around this. But going back to your question, it really is about sort of incentives and so on. Mm-hmm. And there's always people who have, it's been a rhetoric since forever, right? That people are kind of usually unwilling to stand up to it. So also, by the way, the other thing is if you're in Google or Facebook or something, if you start talking about AI waking up, you're probably going to get fired, right? Because these are publicly traded companies. And if some leader of AI like Jan LeCun at Facebook, he can't talk about this because the stock price could drop by 1% or something, and then that's $1 billion or whatever, and no one's happy, right? Whereas, so if you look at other people though who don't have they're not biased by their incentives that way, and just talk about it, that's fine. So I'm not held back, so I don't have a bias where I have to say, I have to be careful about my citation count or anything, so I can talk about it. And there's others too, like Ben Goertzel with SingularityNet. He has no qualms talking about this because he's not held back by being in a publicly traded company that has to worry about its 1% dip in stock price. Great.
Yeah, cool. I want to ask a little bit later about singularity and all those theories. But first, I was wondering, how does artificial intelligence and blockchain technology, how do they combine?
Sure. Yeah. So that is really what we're up to with Ocean. And there's others doing projects too. And I can sort of give a quick survey if you want. But with Ocean, the summary is that AI has centralizing tendencies because of data, because there's an incentive for companies to gather lots and lots of data, sort of become as big as they can, get this sort of data flywheel network effect, and then with that build models, sell. And blockchain, what it can do is if you with Ocean, we've set things up such that we incentivize making data available so you can get paid for your data by the network if you make it available. And others can use that more broadly. They don't have to be within your company or anything. And it sort of unlocks this data economy. And an economy in the sense of there's not just one marketplace, but 10 or 100 or 1,000 marketplaces selling various types of data. Maybe there's 10 million data sets below, and one marketplace might focus on automotive driving data, right, for self-driving cars. Another one might be on weather prediction, et cetera, selling for that. And then on top of that, those marketplaces, you have people doing and consumer level applications, for building a self-driving car or whatever. And then besides the marketplaces for the paid data, you have the commons, right, where the data is free. And with Ocean, one question we had asked ourselves in the design of Ocean was, how do we incentivize, how do we get people to contribute free data? And because, you want the contributor of the data, the creator of the data to get paid, yet no one is paying for it. No humans or organizations are paying for it. So what do? And the answer is you get the blockchain to pay for it, right? The blockchain, just like Bitcoin network, it's paying the miners to add to its security via hashing. Ocean is paying the providers of data Ocean tokens in return for making data available. Right, so they're getting paid already, even if they're putting it straight to the commons where anyone can use it, right? And if those data providers, if they want to charge money for it, they can in various ways. It can be fixed price, auction pricing, whatever. And so that's kind of the heart of what Ocean is doing in terms of this AI setting. So you mentioned before, AI folks say we need more data, and I agree. We at Ocean agree. This is so, and we realized it was all about a supply side problem, not a demand side. As an AI person, you're happy to take as much data as you can. So, that AI model, it's just like this giant sucking sound, taking as much data as it can. It's all about, supplying the data. And so that's why Ocean is incentivizing for the supply side, not the demand side. So that's Ocean. And Ocean overall, we realized along the way, do we want to be, building the data availability service ourselves? And of course, if you look out there, you've got networks that are providing data in sort of a provable space and time storage way, like Filecoin or Ethereum Swarm. And you also have data coming from, you could have it from behind a firewall in a corporation, maybe even encrypted, or you could have it in a centralized cloud like Amazon S3. And we really wanted to be able to support all of these, right? As well as, other sort of decentralized data networks. So we said, in Ocean, let's just have proof that the data was made available. And we don't care where it comes from. It can come from any of these, fully decentralized or cloud-based, centralized, or on-premise. And the network will reward you for it. And at the same time, sometimes you actually want to make sure, if the data needs to stay on-premise for privacy reasons, let's say it's German medical data, it can't leave the German soil, you need to do the compute on-premise. So we actually also said, okay, let's incentivize people doing compute on-premise and returning the results of that. And that looks like basically paying for the services. So overall, you can think of Ocean as sort of an AI compute pipeline where people are getting paid for providing services, whether it's data availability services or compute services.
Mm-hmm. Okay, interesting.
Yeah.
I want to ask one thing about that because you mentioned the amount of data, right? Data availability. But I think one big part of that is the quality of the data. How important is that with Ocean?
Super important. It's critical. And if you actually look at the heart of the Ocean design, we say we want to maximize the supply of relevant data, or more broadly, relevant AI data and services, right? And so when we say relevant, that's quality data. And if you look around in the world of like AI literature or big data literature, data engineering, all this, there's lots of different measures of the quality of data, right? Like, what does the distribution look like and all that? And no one agrees on what the right measure is, all of that, right? And frankly, how does that measure of quality relate to value, right? So we said, you know what? We don't know either. So we're going to let the crowd decide. How? Via curation markets, particularly bonding curves. So how the block rewards of Ocean work is you get block rewards. When you serve up a data set, you can expect block rewards that are proportional to your stake. And that's actually proportional to the log of your stake in that data set. So let's say there's 10,000 data sets, but there's one data set that I think is really awesome and a lot of people are going to want. So I stake on that. Maybe I stake and get 1,000 drops, like Ocean drops of a stake in that data set. And then maybe you ask for it, and the network will randomly pick from me and all the other people that are serving up the data. But let's say it picks me, then I'm going to get paid Ocean tokens as a function of my stake in that data set, right? That's the heart. So if I stake lots and lots, then I can expect to get paid more. And if I don't stake very much at all, then I don't expect to get paid. So you can also view it as the stake is my prediction of the relative popularity of that data set compared to the other data sets. So over time, but it's popularity sort of mixed in with quality, mixed in with prediction of utility and value and all of that, right? But more simply, you can think of it as there's a prediction of this value, this relevance, and then there's the actual value or relevance or popularity, and it's those two things together that Ocean, the expected Ocean rewards, block rewards, is the multiple of those two things, the predicted and the actual.
And I also realize now that you answered this question, that you're looking at enterprise data. And you mentioned before health data. I mean, I was working at a study about statistical data from governments. And there you do have dimensions where you can assess data quality, the integrity of the source and all that kind of stuff. But with enterprise data, obviously makes no sense if the enterprise fakes their own data to achieve an end. I mean, it's just silly.
Yeah, let's say it's super crappy data, right? And I serve it up and stake on it maybe a lot. Well, no one else is going to download it, right? So I'm not going to get paid. Or conversely, let's say that it's really actually great data, but I don't think so, or I don't have money and I don't stake on it. Then I'll serve it up, but I won't get paid very much, right? So it's really when these two things meet, my stake in the data and the popularity, and that's where magic happens, right? And and to be clear on the data, the types of data flying in, the data can come from enterprise, and Ocean, makes it easy for enterprises to onboard because their data can actually stay on their servers encrypted. It never ever needs to leave, and the compute can come to them, right? So this massively changes the flows. In many companies, their crown jewels is their data. I worked in semiconductor industry, chip industry for many years, and they will never ever, or very rarely, let their topologies get out, right? These are the crown jewels of what they're doing. But if they know that compute can come to their side and give them value, and then that's super valuable, right? Mm-hmm. And the other reason, there's privacy concerns, but the other thing is some data is really heavy, right? Like you've got a petabyte of data. Are you going to send that over the wire just to build a model? So there's enterprise data, there's government data, there's data from people, all these sorts of things. They're all valuable. The government data, the NGOs. One of the initiatives we have is working with AI Commons, which in turn is working with lots of different UN agencies, sort of NGO types for different AI for good applications, towards helping the UN 17 Sustainable Development Goals. And so like that's very exciting to us because these agencies, they have a mandate to, share what they learn. They can open their data on day one, but they just don't know how to extract value from it for the good of their people. And that's where Ocean can really come in. And so the vehicle for that is AI Commons and more.
Mm-hmm. Cool. And data commons maybe also, open data.
Yeah. So when we say AI Commons, we mean like for open data as well as open AI compute. And there's quite a few other initiatives out there around open data. And like we embrace them all. We love this sort of stuff, right? And we've had long-standing relations with, the folks at Internet Archive and iterating with people at Wikimedia Commons, et cetera, et cetera. And, this is all, very aligned values. And the cool thing is, if you think about those, there's been lots of initiatives, but there hasn't been a very strong incentive to make that data available or for them pooling their data. And they're always kind of asking for funding, right? But now we can leverage these new tools in the form of blockchains and incentives to actually bring it all together. And that's exactly what we're doing.
Very interesting. Are you familiar with data.world by any chance?
I believe I've heard about it.
Yeah. They're building a social network for data scientists where they can work on data problems together. And basically it tries to kind of standardize different sources of open data. But I don't think they have incentive mechanisms baked in there.
Yeah, for sure. So something like that, like those things like that are really great sort of service providers into Ocean, right? And partners, right? Another great example is OpenML, which came out of KU Leuven, which is where I did my PhD too. And they have 20,000 data sets, some small, some big, of varying quality. There is a rating system, but there's no incentive. So it's that sort of thing, though. Like we can't wait to plug those in and have those as part of Ocean, right? So, one of the quotes that we sometimes have flying around Ocean is, 10 million data sets in your pocket, right? This is part of the aim, right?
You also wrote a blog post a few months ago called Nature 2.0. Can you briefly describe what Nature 2.0 is?
Sure, my pleasure. So at a higher level, it's a vision of the future that points to abundance for humans. And I can flesh that out, but it actually starts with the today of what we have now and what we're building. And in fact, Ocean is one of the crucial steps in between. Ocean and some other related blockchain networks leading us to Nature 2.0. So I'll unpack that now. So once you have Ocean and you can build straight up models like classification models, regression models, that's sort of the starting point, right? That's sort of today's standard data science flows, et cetera. But there's lots of other really amazing branches of AI. One of them, for example, is evolutionary computation, where you're simulating evolution in a computer, survival of the fittest. And I did a lot of work on this over the years. One sub-branch of that is something called genetic programming. So imagine now if you have a computer program that is evolving on a decentralized processing substrate, right? Something like Ocean, right? Where it's evolving, and it's its own DAO, right? So maybe it's evolving and it ends up being able to solve a problem well, and it's its own DAO, so it can even get paid for solving that problem, right? And so you can actually have sort of on-chain evolution, unstoppable evolution even, via genetic programming or other evolutionary algorithms to be solving interesting problems. And they can be narrow or they can be wide. So like an example of a narrow problem is something like an art DAO, such as imagine it's running along and generates art, using genetic programming or deep dreams or something. And it generates that art, it sells that art. Maybe it spends $1 of compute to generate it, sells it for $10, pockets that in its crypto wallet, and then uses that to generate 10 more pieces. With that, it sells 10 pieces for $10 each. It makes $100. And it repeats. Before you know it, it's got $1 million. You've got the world's first AI millionaire, right?
That's cool.
And you might say, well, does it actually own that? And the fact is, corporations are people too. So you can do like the guys at the DAO did, where they incorporated in their DAO in Switzerland, in Zug, Switzerland, and of course, you're in Switzerland, so you can incorporate in Zug, have a DAO, and then you can basically remove the people essentially in a practical sense. So then you just have this DAO that has personhood as a corporation. Malta has actually already made it easier, but this is the pre-case, if you will. So basically, imagine you're doing like the guys at the DAO did, but now instead of just a regular DAO, a dumb DAO, you can have an AI DAO, where you've got AI like this art DAO that I'm talking about, right? So now it actually literally has the rights to that art, right, or to the money that it makes. And Malta will make this much easier too, or has made it via its new laws, and other jurisdictions will follow. So that's sort of a very narrow example. But then once you start to say, okay, it's got this code for generating this art, but what if that can evolve, right? Like genetic programming style. Just like we had, Ethereum was the first sort of Turing-complete blockchain. Well, genetic programming has always been, the first Turing-complete AI, right? So we've got Turing-complete AI running on Turing-complete blockchain, and that's an explosive combination. And so I'm pretty excited about that. But overall, with these AI DAOs, from the Arch DAOs, what else can you have? Well, think about Uber, right? Uber has this network of cars owned by the drivers, and Uber's moving to the self-driving cars, right? Now, Uber ideally would want to buy all those self-driving cars to own them, right? But that's a huge capital expenditure, right? Mm-hmm. And right now, Uber has managed to stay relatively capital light. It's really just a network, right? It spent all of its billions of investment in just building out, the IT and the marketing to kickstart cities, right? But is it going to spend, 10x, 100x more in order to buy these cars? Probably not, right? Now, it could try to set up something where people buy the cars, the self-driving cars. But imagine instead where it goes to the Daimlers of the world and says, hey, Daimler, you created Car2Go, which was basically creating your own customer for these, this car sharing network. Now we want you to create, 1,000 cars to run in the Uber network in, say, Berlin, where I am. And each of those cars, it's going to be its own corporation as a DAO. It's initially going to own, have this lease, and it's going to pay back that lease to Daimler over the next 2 years, right? How's it going to pay? Well, via Uber rides, of course, mm-hmm. right? So at the end of that, you basically have in 2 years, 3 years, however long it takes to pay these cars, each of these cars owns itself and it's fully paid off itself. It's running around. It's a self-driving, self-owning car, right? And actually, myself and some friends came up with this, and then we looked at the genealogy, and there's been other people thinking about this. Mike Hearn was talking about this back in 2011, so it's always nice to learn some other people who came up with this before. But I'm very excited about this and happy to give credit. But what's cool is Ocean is going to make this stuff this stuff possible, right? It would have been really hard to do on Bitcoin, mm-hmm. near impossible. But Ocean is really meant for this, right? And remember, Ocean lets these other networks plug in as services, so you can have Singularity Net or Golem or Enigma or any of these guys plugging into Ocean for the things that they're good at, AI-specific compute, privacy-specific compute, et cetera, et cetera. So on this Nature 2.0 thing then, imagine you have these cars, and you also do it for self-driving trucks, of course. You also have a DAO for every road that people have invested in, et cetera, for every bridge, for the electric grid, all of this. So we have all these things around us, and they are... each of them are self-owned. They don't really have a sense of identity. They just are, right? And they're kind of providing this sort of next generation infrastructure for society, it's sort of this cradle of infrastructure. And if you think about it, get rid of technology, rewind, a few thousand years, what is nature 1.0, right? It's the wind at your back, it's the soil at your feet, it's the lions running around that you hunt maybe, or the deer probably more likely. And everything else, right? And this is sort of like, each of those things, they're just sort of there for as sort of this cradle of civilization that we can live off of, right? And use, and it sort of helps us to grow ourselves and us participate in that ecosystem, right? Mm-hmm. Well, Nature 2.0 adds silicon and steel, right? So it adds these AI DAOs as infrastructure that, once again, it's just sort of all around us, right? It's sort of self-owning, you can't really control it, but it is actually helping to provide infrastructure for that ecosystem, for humanity, et cetera, right? And it plays well with Nature 1.0, et cetera, too. And that's really what Nature 2.0 is about. And it kind of reconciles nicely with a lot of other narratives, things like, energy deregulation. What does that actually look like? Or, urban mobility as a service, all that, fully decentralized. It sort of synthesizes all of those ideas into this, very one short catchphrase, Nature 2.0. And there's another really, really cool thing too about it, and that is the following. So AI, it's pretty amazing, some of the applications so far, right? But also, there's 3.5 million truck driver jobs in America, right? More than 1% of the population. In the next 10 years, all those are going to be gone from self-driving trucks, right? There's already been self-driving trucks in production. So you've got 3.5 million truck drivers that are going to be pretty angry with the world, right? Maybe they'll get new jobs, but are we going to replace those jobs that fast? Probably not. We can hope it's true, but wishing doesn't make things true, right? And same thing with the taxi drivers, et cetera, Uber drivers too, right? So we're going to have millions and millions of people probably without a way to feed themselves in many cases. Can we expect 100%? And it's not just that; it's a bunch of other jobs too, right? Even the creative jobs, creative AI, all that. So AI is going to actually like decimate so many jobs, and the question is, and that could lead to like political revolutions or revolts. All this, it could be really like disastrous, right? But at the end of the day, what these people really want, at the very least, is to feed their families, right? That's what they're fighting for. So what if we had a way for them to feed their families? And of course, this leads to the idea, well, UBI, right? And normally, traditionally, we've always said, let's convince the governments to have UBI, right? But if you think about it, blockchain actually can handle it very well. So for years, most people in the blockchain space have realized that UBI can solve the distribution problem really well, right? You have a UBI chain, it's running, and anyone that signs on to that with some sort of basic proof of human, doesn't have to be perfect, but handle most spam, then they get the reward. So let's say there's 100 people in the system, and $100 worth of credits comes into the system, then each person gets $1 immediately, right? That's a very simple implementation. You don't even need an incentive scheme, which is cool. So now, though, imagine we've got all these self-driving, self-owning cars and trucks and power grids, etc. And after, say, 2 years, the car is paid for itself. You know what it does with its surplus? Off to the UBI chain, right? And so over time, basically, it means that, AI has taken away jobs, but guess what? It's given it directly back into UBI, Universal Basic Income, that has no rules. As long as you're a human, you get dollars, as long as you've signed up. That's it, right? And so now, basically, we can make this transition from a traditional assumption of scarcity, zero-sum game for dollars, etc., to one of abundance, where you have this rising tide. And at first, if you get $1 a month, $1 a month, who cares, right? But guess what? That will make a huge difference to someone in rural Africa, right? So bit by bit, it's going to make a bigger and bigger difference to more and more people. And as more of these systems comes online, that's that leads us to the sort of Nature 2.0 vision of silicon and steel as this upgrade to the cradle of civilization.
Really fascinating. I mean, this is one of my favorite topics anyway, because just recently I got into an argument with somebody, and I was asking, how long will it take until somebody taking a bus will pay the bus driver's salary directly to the bus driver? And that other guy said, that's not going to happen, because you don't pay for the bus driver, you pay for the ride.
Exactly.
And you just answered that question.
Yeah, and another way to think about it too is, there's sort of Maslow's hierarchy of needs, right? And at the bottom level, you've got, the basic needs, food, shelter, clothing, all that, right? So imagine, we have a network that provides energy, right? Proof of energy. And, you have all these people, energy miners, but instead of using electricity to add security like Bitcoin, they're actually providing energy to the network, and the network pays them back, right? And there's actually a project for that, Blocks/Verve. And there's other energy ones too, but that one's actually incentivizing that directly, right? There are some emerging projects where you have proof of move of human for cars and for drones and stuff like that. I would love to see. I'm not aware of it, but proof of food, right? Proof of food going into someone's mouth or getting supplied to someone's house, right? So basically, we can have a network or two for each of these basic needs. What if we can go up the hierarchy and we can have proof of learning or and so on? Mm-hmm. And what this can lead to, bit by bit, we don't just have sort of universal basic income and universal basic sustenance. We have universal self-actualization, right? And what does that mean? Well, it's whatever you define it, right? Like, I have a different idea to self-actualize myself than you might. And other people, maybe all they want to do is play Nintendo in their basement. Fine, that's okay, right? And people can do whatever they want. But giving the opportunity to people to do so. And, they might say, oh, well, I only get meaning from my work. Well, great, keep doing work. You just don't have to worry about getting paid for it anymore.
Let's take a quick break for a message from our sponsors. This episode has support from no official sponsor, but from my very own The Blockchain and Us newsletter. Get an email from me every 2 weeks with a very short summary of new podcast episodes, so you can immediately pick those interviews you'd like to listen to. To stay up to date, just visit www.theblockchainandus.com and sign up today. But I think while you were explaining all this, I thought that all of this vision, I think it will only work if it's fully decentralized. I mean, once you have just a pocket of centralization and silos, then it will fall apart.
Well, I wonder if that's true, because right now you might argue that, we have not just a pocket of centralization. We have actually the whole world decentralized except for a few pockets of decentralization.
Yeah,
so
exactly.
But
that's why that vision sounds so fantastic currently.
Yeah. So overall, though, I see that over time, it will end up where it is possible to end up with nothing but decentralization everywhere. Or maybe there will be pockets of centralization, and that's okay. But the cool thing is, anyone, like, if you're a human, why wouldn't you sign up for a UBI chain where you basically get free money, right?
Sure.
And as time goes on, then money will start to matter less and less. You know, like when you watch Star Trek, do they ever talk about money? No, they just assume that everything is provided for, right? And we can get there, right? Like AI and other technology and blockchain actually really help to make the economy far, far, far more efficient, right? Like we can get our basic needs met for far cheaper than before, right? So, you know, blockchain can help to coordinate the movement of those atoms into your belly or et cetera, to feed you, to clothe you, et cetera. Right?
Yeah, exactly. I mean, you mentioned DAOs before, right? Every street will be a DAO. Maybe a supply chain for food will be a DAO as well. But who invests in these DAOs?
Well, you know, you have to just look at it case by case right now, I think. So overall, an example, you know, there's a DAO, each car is a DAO, right? Each self-driving car. Who would create that initial car?
Right.
Well, Daimler is incentivized because then they can create their own customers. And like I said, they already did that with Car2Go, right? They created Car2Go to manufacture a customer for themselves, right? So Daimler would be incentivized to manufacture all these cars for these self-driving car networks. Same thing with these, drone networks, et cetera, et cetera, et cetera. So if you're a smart company, you can actually create these customers for yourself and then make yourself just part of the overall as a supplier to that, right? But of course, you have to set up where you're not the only supplier. You just might get an initial advantage because you were the first supplier. So you get an advantage for a year or two or three, right?
Yes, but if you're a company, then you want to extract rents.
Well, that's the current company, right?
Yes.
But so I what I see is that, you know, this is all about like organization of people, right? And you know, but before we had writing, the only way to organize people was, you know, shouting or just like talking with people in a small village or whatever, right? That's all you could do. And then when we had writing, you know, before the days of the printing press, but with writing, then we could write down some laws and so on, and some commandments to our armies and stuff, such that we can organize in larger units. And then along came the printing press, and we could organize even more efficiently, such that, for example, we could write a constitution and then print that out for all the people to read and to post on their walls and so on, right? And each of these technologies allowed us to have they unlocked better and better forms of governance, right? That weren't possible before because the technology would have been too high friction to implement. So it increases the design space for possible ways of organizing humans or governing, right? And what I see that blockchain can do is that it massively unlocks a much bigger design space for organizing humans, right? And in the case of the corporation, the big thing there is like corporations, to organize the people within a corporation, they have one overall objective function, if you will, and that's the value of the shares. It doesn't matter if you know, especially if they all have options or shares in the company, right? So then you've aligned the incentives. You know, it's sort of this hierarchical design problem, but you're aligning incentives from the lowest employee at the bottom of the pyramid to the CEO and everyone in between. And then you know, with Coase theorem, the idea is, of course, where you want to minimum communication costs traditionally between enterprises are expensive. So having everyone within the same firm allows you to reduce the friction of communication and so on. But once you have blockchain, then the cost of communication is much, much lower, especially when it comes to communication of value, you know, transfer of value from individual A or individual B or group A to group B. And it basically then means you can start to dissolve the need for a corporation. And then the question is, how do existing corporations transition, right?
Yeah.
You know, if you're Facebook, what do, right? You see that 10 years from now, you're going to just get creamed by these decentralized networks, you know, Akasha and the like, right? So what do you do now, right? And, you know, it's classic innovator's dilemma, right? What do? Do you try to invest in them, or do you try to buy them, or do you stick your head in the sand? And some corporations are going to stick their head in the sand, and they will get creamed. It might take a long time, but they'll be gone, like Kodak, etc. Notwithstanding Kodak coin. But you know, other ones that are courageous can actually do something about it. And what's cool is blockchain gives them something to do, specifically tokenizing. So you can tokenize Facebook, or Facebook can tokenize itself. And what I mean by this is there's a series of steps, and at the end of the day, Facebook becomes a network. You know, the Facebook shares become a crypto token, you know, FP, right? And so the steps are the following. Step one is Facebook tokenizes its security. So all the shares get converted to crypto tokens that are then shared on the crypto exchanges. And what's cool, this is actually already possible. You know, Delaware passed laws in the last couple of months to do this. France as well, and other jurisdictions, have done it or are coming along. So that's just happening, right? So, and that is actually kind of a no-brainer for any company because it improves the liquidity of their shares.
Sure.
And the access too, right? That you just have more global access, so greater
security
demand.
Tokens.
Exactly, security tokens. But you don't need to stop there, right? That's just reducing the friction in ownership. But of course, I can already buy shares in publicly traded companies. It's just higher friction. So what you need to do is you need to transform the overall organization from a centrally controlled corporation to a network where it's rewarding based on value added to the network, right? Just like Bitcoin, it rewards for value added in the form of security via hashes, Ocean in terms of data added, et cetera. So with Facebook, it's really about each Facebook division for starters. So and same thing with Amazon, et cetera. So Facebook has Facebook Messenger and WhatsApp and all of these, and every single one would be its own tokenized network, right? And so for say Messenger, right? It might be very simple. It might be if you run a node that you're incentivized to run a node because maybe it does some security and you get rewarded for minimizing the latency, passing a message along, right? And it could be as simple as that, but there's lots of possible token designs. And there is for each of these things. So let's say that Facebook decides, okay, we're going to tokenize Messenger. They do it like I described or some other thing. And then they just launch that network, right? And maybe they say with this network, 50% of the tokens go proportionally pro rata to the shareholders, and the other 50% go to the users of Messenger, people who have been using Messenger, and you get tokens proportionally to how much you've used it, or maybe just equally among all the users, right? So that's one way. And you do that then, and you do that for each service. And then what do you do about Facebook, the company itself? Well, remember, Facebook, the company, then it has no products left. So, but the people, if you do it right, you know how Dash has on-chain governance where there's bounties? It prints out some of its money where people can make proposals to improve Dash in certain ways. And there's other ones like that too, but Dash is a nice example. Well, now Facebook can be doing the same thing with these networks. So an engineer or groups of engineers that previously worked for Facebook can be providing services to improve the code, et cetera, of each of these networks, right? And as well, Facebook itself runs its own infrastructure right now that's already taken care of because that's built into the incentives. So the summary is the incentives can incentivize not only the running of the infrastructure and incentives around growing that, but also the improving of the code, et cetera, like Dash style, et cetera. So, and then basically Facebook itself has melted into the network. It's melted into the community, right? And that to me is a really, really hopeful vision. And I hope it happens, right? And I think, maybe these networks will merge or play well with each other, Facebook with Akasha, et cetera, et cetera. We will see.
Interesting. Very fascinating. I mean, of course, I'd also love to see this happen. But have you spoken to anyone at Facebook about this?
I'm not sure if I can say more there.
Because what you mentioned there, I mean, there's just so much. I love these visions and I'm all for them, but there's just so many arguments you can make against a company like Facebook wanting to see that happen in reality. Yeah,
so maybe I can give a more broader answer, right? So at a higher level, right? Put yourself in the shoes of Zuckerberg, right?
Sure.
He started out, just hacking away, merrily building this thing, and his friends joined in, and their friends, and he was just on this rocket ship for more than a decade, right? Kind of amazing. And at first, it was just playing and hacking, and then over time, the vision coalesced into connecting people, et cetera. And Facebook has grown in a lot of ways, and Zuck himself and so on. But at the same time, now they've arrived at a place in the last few years where it's like, oh shit, we're people farming. We didn't mean that. And I've hung out at Facebook a lot, right? I have friends who are early employees, all that. So hanging out at Facebook HQ, and they're good people. They mean well, all that. But something happened very slowly, and then there was clear problems here and there, such as, oh crap, we helped enable the hacking of the U.S. election, right? Because of Russia, we have Trump as a president. Oh my God, right?
Right.
And Facebook was the vehicle for it. Oh crap, right? And that's not the only problem. There's lots of examples like that are this isn't what we meant, right? What hath we wrought, right? So and then there's I talked about this transition from being a neutral platform to sort of a media company. Did they really want to be censors? Did they really want to be kings like this? Well, they are, whether they wanted to or not, and that is a very uncomfortable position to be, right? And it is an extreme amount of power. Governments rightly are threatened by them. They have 2 billion citizens and more money than most countries, right? So is that, and overall is that, so if you put yourself in the shoes of Zuckerberg, these are really uncomfortable questions. And if you look at the interviews that he's had, he stumbles through a lot of things in a very rough way. He tries his best, but he's in a really tough position.
Mm-hmm.
But what I see is that by tokenizing, it's actually a very clean way to address innovators' dilemma, while potentially adding a lot more shareholder value, right? Well, who knows? We don't know. We've seen examples of tokenizing, but only smaller scale, right? Numerai is one example, partly, as well as Kik, right? And Telegram's happening bit by bit. But we haven't seen bigger ones yet. And to me, the ones that figure it out and do a good job of it can, repeat that. And, imagine 5 years from now, 15 years from now, every single Fortune 500 company is tokenized. Or maybe half of them they are, and the other ones are dead because the upstarts killed them.
Right. Yeah, exactly. I mean, how likely is it? I mean, you mentioned Facebook, and also, I mean, there was recently there was this petition at Google, right, where some of the engineers petitioned against the China initiatives of Google, and so basically that's maybe a start where the people actually building the thing say, wait a minute, that's not what we want to build, even though it may make money for some people, it's not what we want to be part of. But how likely do you think that these big current tech companies, Apple, Google, Amazon, Facebook, Twitter, will be around in 5 to 10 years?
10 or 15 years from now, I don't, anyone that is making its margins and raw value on data, like basically this data arbitrage, realizing they know the value of the data much more than their users do, and their users are giving it up. Mm-hmm. That they are totally exposed that way, and not to mention on data liability with things like GDPR and all that, right, or being honeypots or being hacked, et cetera, right? So, it's actually maybe they'll be around, but there's a good chance they'll be either attacked from below or attacked by regulators or broken up and so on, right? Like Facebook is at risk of getting broken up, Google, et cetera, right? Yeah. Or at least Alphabet. So now here's another cool example, though, and maybe this is a better one. Will Facebook actually do this? There's a country that's doing this, Estonia. Estonia, it's an amazing country, right? They after the wall came down, Estonia became its own nation again rather than part of the USSR, mm-hmm, and went digital immediately, actually. So, and there's sort of an A/B test with them and Latvia next door, where Latvia didn't go digital. And, fast forward 20 plus years, and Estonia is the sort of like model of innovation and the future. And they have, they've had e-residency for 5 years. They've had citizenship. They have with 30 government services that are all electronic, including health, et cetera. And it's just this really amazing model. If you're in the government and you want to pass a bill, you actually submit that bill to yourself and all of your colleagues in the government and the prime minister, et cetera. And everyone signs it asynchronously with their digital signature. It doesn't have to pass from one house to the next and take 2 months. It just happens within a day. And so, and it was actually, by the way, the reason they could do e-residency was they managed to ship it, the first version super fast, super cheap. I think they took their existing citizen identity card, they scoped it down, and they just rolled it out for a budget of less than 100,000 euros, I believe. And wow, and that took off, and now there's more than 30,000 e-residents. And this, if you think about it, is super courageous, because they are giving rights that only normally go to citizens, and they're giving some of those rights to anyone in the world. To start a company in Estonia, therefore a European country, and it makes it easy to do business with the rest of the world as a government vetted source of identity. All of this, right? So, and I was an advisor to the Estonia e-residency program. Got to know Casper, who was running it. A visionary guy, right? And the team around him, just incredible. And so what they started to iterate towards was realizing, okay, we've done e-residency. We get blockchain. They really, truly do. They're really visionaries. It's really awesome. And they said, well, what if we tokenized Estonia itself? What does that look like, right? And this is the government itself asking this question, right?
Interesting.
And they said, and Casper put out a blog post about, they called it Estcoin. And, they kept it pretty vague on purpose because they wanted to see feedback. And they got lots. And it was generally very, very positive, saying, we'd love to learn more. Tell us more. And so, and the government has kept proceeding on that, right? Towards that. So Estonia is on this trajectory to tokenize the country, right? So what I could tell Zuck, Zuck, look, a country is tokenizing. Surely Facebook can.
Yeah, right. Well, only that maybe one argument against that would be that the country has a mandate to care for its citizens, while Facebook cares for those who hold the most shares, right? So maybe I'd like to speak a little bit about your work as a token engineer. Just roughly, I'm wondering, how does the process of token engineering, what does that look like?
Yeah, so I mean, the backstory of this is I'm trained as an engineer, electrical engineer, out of University of Saskatchewan, Canada, in the mid '90s, right? And a very rigorous training, right? Like tons of math classes, tons of like really hardcore analytics, all this. And then I spent my career building tools for engineers, right? So like lots of like heavy duty engineering methodology. I have a PhD in engineering, all this, right? So I sort of lived and breathed the world of engineer for many years, as well as sort of had another foot in the sort of AI researcher door and stuff, or side. And even in the days as an undergrad engineer, we had it drilled into us the importance of responsibility of the things that you design, the things that you create. There's classes on engineering ethics that we would take, and we would watch videos of like the Tacoma Narrows Bridge collapsing and why this could have been prevented if the engineers had been more responsible, right? And so then, if you think about the blockchain world, we have rhetoric where, oh, I'm just going to throw some code out there and I'm going to see what happens, and code is law and it doesn't matter and ethics don't matter, it's all about the code. And I'm like, no, it's not. Like AI and blockchain especially are two technologies where every single piece of code you write, every single line is extremely ethically infused, right? And you need to take responsibility for that, or you should. I mean, at least this is my view. It's my view. People can choose whatever views they want, but overall, if we're creating infrastructure for civilization, at least to me, we ought to be thoughtful about it, right? People can choose however they want to do things, but my kind of goal is towards this, idea of Nature 2.0, as opposed to sort of like one of many dystopian scenarios, right? So, and so I have sort of like, part of the reason that I paint pictures like Nature 2.0 is saying, okay, here's what we can head towards. Now, how do we get there, and how do we minimize the chances of screwing it up, right?
Right.
In one of many ways. Mm-hmm. So then, this is sort of the backdrop as an engineer. And fast forward to when we started working on designing the actual dynamics of the Ocean token. At first, we were, whiteboarding a lot, right? This was in April, May, June last year, 2017. And we were whiteboarding, one design, then another design, and we were looking at pricing models for data markets and all this, and we found ourselves flailing at first on the incentive scheme, et cetera. Mm-hmm. So we said, you know what? Tokenized ecosystems are a lot like optimization algorithms, or design of optimization algorithms, where you have to give the specifications, as in the goals, as in two things: the objectives, the things you want to maximize, minimize, and the constraints, the things you have to meet. And then you have a design space that the sort of agents run around in and try to do better against those objectives and constraints. So that's the first thing, and that's essentially the problem definition, right? That's the problem definition for optimization, but also that can be the problem definition for a tokenized ecosystem, where the agents are essentially the miners or any other participants that participate with stake, et cetera. And then the objective function is actually the block reward function. So that's the first part. The second part is, once you have these three things, then you say, what are some possible designs? And you start with the simplest thing that could possibly work. And that usually is actually no tokens at all, no blockchains at all. Like, can I run just an old school database on this, and will it solve my problem? And if it does, then you shouldn't use a blockchain, right? Because you've already solved your problem. And then the next thing you should try is a blockchain without tokens, maybe one that acts like a database, like super easy, and BigChainDB is exactly that, right? It doesn't have its own incentives, it's not meant to. And if that doesn't work, then you start adding in building blocks from the corpus of blockchain building blocks, according to what you might think work, right? So a common one is TCRs, token curated registries, lists, or maybe a bonding curves. But maybe you're just going to do a governance scheme, so just have a very simple governance plugin. Maybe using something from Aragon or otherwise, right? Or maybe you have, and there's a lot of different building blocks around different things. Third-party arbitration and governance and curation, proof of, and at the heart of things, you need to prove that something was happening, right? Proof of work of some form, whether it's training a neural network or adding security in the form of hashes. So, and basically what you do is you try a building block. If it works, great, you stop. Or if it doesn't, then you try something else, and you try to basically keep iterating with minimal add to complexity until you arrive at something that meets your objectives and constraints. And usually as you're going along, you actually end up adding a few more constraints and maybe even changing the objective, and that's okay. Mm-hmm. And only if needed should you actually come up with a new design of a building block. Why? Because it's actually a huge amount of complexity if you do that, and you're doing something that's untested and so on. And sometimes you have to, but hopefully you don't. So in the case of Ocean, actually, we tried a whole bunch of schemes. In the end, we added a new building block, but it was the minimum possible riff on an existing one. So there's traditional bonding curves. that, Simon Delourier did a lot of work on with curation markets, etc. And we said, let's add proofs to that, where you basically can get rewarded as a function of your stake in the bonding curve times, work or not, right? Mm-hmm. And I talked about that earlier. So that's basically what we arrived at. And we decided, this was a really useful process that we went through, and we saw how the clouds really cleared, the clouds parted when we decided to follow this rigorous methodology, because we knew when we were done the design. And as soon as we were done in the design, we just wrote it down on a white paper. And that took some time too, but at least we had a design that we felt good about. So we wrote about it in a series of 3 blog posts, the main title being Towards a Practice of Token Engineering. And it really resonated well with the community. So, I gave some talks about it and other colleagues, and now, and we decided, let's help to kickstart a community. And there were some other like-minded folks around us, people like Michael Zargam and Dimitri Zhang and others. And so this community has actually formed very quickly, and it's a really awesome community, and we're all teaching each other a lot. And that's really what it's all about. So there's already about 10 meetups throughout the world. There's been about 3 or 4 sort of global gatherings. There's a lot more coming along. So it's a really exciting thing. And basically it's, we're at the level where now that, Ethereum has matured enough, then we can start thinking a lot more about rigorous design on top of that. And that's really what token engineering is about.
I told you before, I spoke recently with Anish Mohammed about token engineering. And one of the things he said that was quite interesting was that he said, globally, this is such a small group of people understanding all the things that matter in this field that there's actually a little bit of an imbalance happening there. It's very, very left-brained. It's very male-dominated. So how important do you think in this work, in software engineering, token engineering, and AI, how important do you think are the more right-brain skills, like creativity?
Well, I've always been a big believer that you need left brain and right brain, and you need to balance them. And I think, men and women have both sides. Everyone has a full brain, right? So you just have to get good at using both sides. So in that sense, I think it's super important back and forth to hone and practice skills across the board, right? Mm-hmm. And I've written about this where I think actually the people that are the most successful in the field tend to be the polymaths who are actually experts at several fields, but also good at building bridges between them and figuring out how to connect long-term visions with the day-to-day practice of execution, right? And that's actually coincident. Well, interestingly, and probably not coincidentally, that's what VCs look for in investing in companies too. They want vision and execution, right? Mm. And vision actually both actually have a lot of creativity involved as well as skill, right? To have vision, you have to have creativity, and to be able to execute well, you have to creatively explore your building blocks and so on. So, and the ethics side is super, super important. And I think that hasn't been emphasized as much as it could have in the space. And, I think that's a practice where many of us have been talking about it, and there's practice towards there too. One other thing about Anish too, he's a true polymath, amazing person, and he actually also had a nice hand in helping us with the token engineering of Ocean. So, full kudos to Anish. We go to our way to say thank you to everyone, and there's a lot of people who contributed to the design of Ocean Protocol. It's really a community effort that way, and I'm thankful, for sort of having been in the community several years, that I could actually reach out to my friends, the experts, and get feedback, and that really helped.
Yeah, cool. How do you, and maybe also your friends and your peers in that group, how do you guys train creativity?
I don't know if the blockchain people are experts at that per se. It's overall, I do have philosophy about creativity. A lot of people think that creativity is just this innate thing, and you either have it or you don't. I think that's a load of BS. I see that actually in the late 50s, there was a movement around how to get better at being creative. And there was a lot of books written on it. One of my favorite books of all time is called Applied Creativity. And it actually gives a bunch of tools about different tactics and techniques to generate ideas. Mm-hmm. For example, if you're trying to create a startup, maybe you make a list of underexploited technologies, and you make another list of interesting problems. And then you say, okay, for this first underexploited technology, how can we use this on this first interesting problem, on the second, on the third, on the fourth? And you go through that on the sort of n times m combinations, and you see what pops out. And maybe 1 or 2 or 3 will pop out from the top of that. And you might think, at the end, it'll look like this amazing idea, but it's just because you went through this in sort of a rigorous fashion. And that's just one example of a creativity tactic. But there are dozens, right? And you can actually get better at it over time. So I think, maybe some people are naturally a bit better at creativity than others, but there's a lot where you can improve that skill. Mm-hmm. So that's all.
Yeah, no, definitely. I think it's extremely important, and it's very easy to forget that it's also actually very, very valuable in this space. Um, Trent, you're currently living in Berlin. And how important is being in Berlin at this point of time for you?
Well, maybe like overall, I would say for the space, I'm really happy that blockchain is probably the world's first global tech ecosystem, right? There's no single center of gravity in the whole world for blockchain, right? And that wasn't the case for Web 2 or Web 1 or any of that, right? Web is and chips, Silicon Valley largely, or automotive was Detroit. Now we've got it a bit more spread, et cetera. And blockchain really, there's 10 or 20 cities. That's probably this power law distribution of sort of relative impact. But I really love Berlin. I've been here many years now, and part of the reason I came here and part of the reason I stayed was it has this bias towards society and hacking. So it's really about impact via creative technology, all that. I came to Berlin when I first came to Berlin. One of the first things I did was go to Room 77, and that was the very first bricks and mortar place in the world that took Bitcoin for anything. And not only did they take it for anything, they took it for beer. So I was very happy. And, I went to this Bitcoin meetup, and everyone around me was talking about Bitcoin and blockchain. And I'm like, wow, I'm home. and it was not just about building, but it was also like about society, right? And as I learned more about Berlin and also knowing the history, there's actually a long history of Berlin for sort of obviously tolerance, but also hacking, hacker culture, all that, right? C-Base was one of the first hacker spaces in the world, started in the early 90s. There's the CCC conference, all these sorts of things. There's quite a few projects that are quite prominent. A lot of the Ethereum core devs are here. There's Ocean and BigChainDB, our projects. There's Parity, there's Cosmos, there's Gnosis, there's Lisk, and many more, right? And so, and the cool thing is, the community is really supportive of each other, right? And I think that's, a natural outcoming of blockchain, especially if it's not about, if you have this assumption of positive sum game versus zero sum. And here in Berlin, it is like that. And I'm really happy. I hope it stays that way. I think it will. We will see, right? And I would say it's a bit different. A lot of my friends in Silicon Valley who are longtime entrepreneurs and builders, they often ask me questions about well, what's the business model, right?
Yeah.
How do we make money from this, right? I'm like, that's not the point, right? The point is how do we make an impact to society, and then how do we keep feeding ourselves to do so, right? And we know if you build it and if you're patient and if you really go out of your way, the cool thing is value can accrue, but you can't aim for it directly, right? And sometimes you have to be patient. Some projects are taken off. We watched Ethereum grow up and blow up in a great way, and I'm super happy about that, right? In the sense of a lot of people are, don't have to worry about money anymore in a great way, and a lot of early Bitcoin hodlers that were at those meetups and stuff, it's like that too, and that's wonderful, right? I can't think of better groups to not have to worry about money anymore and instead focus on building, right?
I mean, there's this saying, right? And the people that surround you, that's how you become later down the road. And it's great that you found a good place like Berlin. I definitely love to be in Berlin, and I think it's always fun there.
Yeah, I should mention too, by the way, I'm not anti-Silicon Valley. I have many friends there, amazing thinkers, all that. It's just sort of the approach to money and growth, the idea of growth at all costs, nothing else matters. It's well, no, how about impact on society and helping your friend and growing as a person, right? Mm-hmm. So, I once said, Silicon Valley is growth at all costs, and Berlin is growth as humans, and that's probably a good summary.
Yeah, cool. Trent, do you have any role models?
Sure, yeah. Probably my very first one that I always refer to as Ben Franklin. He was initially a successful entrepreneur where he, had this printing press in Philadelphia. And in order to do well at printing press, he actually wrote a lot, writing Poor Richard's Almanac, coming up with quotes like an apple a day to keep the doctor away, right? And, he just did that. But then he was very successful at that. And so he was able to not worry as much about feeding himself anymore. So then he could focus on science. And he, connected electricity with lightning via the famous kite experiment. And that was actually basically the beginning of electricity as a science, right? And Ben Franklin actually iterated with the Royal Society in London and worked a lot with, across the Atlantic back and forth to sort of improve the practice of science. And that was kind of wonderful. And if that wasn't enough, so he went from entrepreneur and writer to scientist and thinker. And in the twilight of his career, if that wasn't enough, he co-invented the United States of America. And and it's like, oh wow! And there was 2 battles in the after they declared independence. Like he was the only person who had a hand in all 3 founding documents, right? The Constitution, the Declaration of Independence, and the Bill of Rights. He was the only person. And there was also John Adams and Jefferson and these guys, and they're all amazing. But Franklin, he had a hand in that. And did you know the UK could only send half its ships across to America to fight? Why? Because they had to keep the other half around to defend against France. Why? Because Franklin was ruffling the feathers of France so that France would cause consternation to the UK. So basically, Franklin literally fought half the war for the USA. If the UK was able to send all of its ships, the USA might not have won. So this to me is really wonderful. And it wasn't just Franklin. Others were around too, like John Adams' son, like Quincy Adams. But overall, really, that's a wonderful role model. Someone who jumped across multiple fields, managed to, he's sort of the penultimate example of self-actualization. And, I really aspire to be like that. He wasn't a perfect man either. He had faults, but overall, really wonderful inspiration.
Cool. And he defeated the British.
Oh, no, not single-handedly. Obviously, Washington and all the troops around. But it was really a 2-pronged approach. And, it's kind of amazing that just a handful of people, especially Franklin and John Quincy Adams, really made a huge difference on the French-British side.
I mean, do you see like a similar battle going on, between maybe the ideology of what blockchain can do and what's currently happening with these data silos and people farming?
Well, there are going to be battles. Some of them will be probably bloody. I hope not. This is why I'm always a build-it-up sort of person, rather than saying, hey, Facebook, let's fight. I want to say, hey, Zuck, let's tokenize. We can help you, right? And to me, that's actually much more healthy. Let's build the future together, right? If someone wants to stay in their sort of rent-extracting regime and fight, and some will, then game on. Let's fight.
All right, cool. Well, Trent, I really enjoyed this conversation, and I actually realized I have so many more questions that I wanted to ask. Also, stuff about Estonia and e-residency, but maybe we can revisit this in a future conversation. And again, I really appreciate your thoughts and insight, and many thanks for making time today.
My pleasure. Thank you.
Thanks so much for joining us today. More info on our guest and our sponsors is in the show notes of this episode and on the podcast website, theblockchainandus.com. To help people find this podcast, it's important that you download, subscribe, and give it a top rating and review on iTunes or on the podcast platform of your choice. I'm Manuel Staggers, and I thank you very much for listening.